All right, we're excited to kick off our morning session looking at large language models and artificial intelligence. It's my pleasure to introduce our first speaker, Eva Vivalt. Eva is an assistant professor of economics at the University of Toronto. Her research focuses on guaranteed income and cash transfers, how decision makers interpret evidence, and how we can learn across studies. Eva received her PhD in economics from UC Berkeley, and we're excited to welcome her back to our campus. She and Stefano Della Vigna, who is also here and a member of the BITSS Advisory Board, are the co-PIs of the Social Science Prediction Platform. Thank you, Eva.
Great, thank you so much. So very excited to be back here presenting this work, which is joined with Stefano Della Vigna on some results from the Social Science Prediction Platform. First, to set the stage, since this is the first talk in the morning session on AI, this is a plot maybe some of you have seen before from Meter, which looks at how LLMs have been improving steadily over time. And in fact, what this plot is showing is how long they can sort of displace human tasks for. So they can potentially successfully complete tasks that take humans from just a few seconds through to 10 hours plus. And of course, I think we can all think of times and cases where LLMs can save even much more time than this. But the point here is that you can see there's been this dramatic explosion in the capabilities of LLMs, which has implications for how we do research. So I'll be talking today about forecasting, drawing on things from the Social Science Prediction Platform, which is this platform that Stefano and I set up to allow researchers to collect forecasts of what their own studies will find. There's several potential uses of this that fit in very well with the theme of this workshop today, namely, it might, in the long run, help to mitigate publication bias against null results, because the null results, if they're surprising, maybe there's more incentive to actually publish them. It also ties into some of the stuff we were talking about earlier with Bayesian analyses. They can provide priors for Bayesian analyses, as well as experimental design. So our main focus is really on this forecasting of research results, including summary statistics, like your first stage, your take-up rates, say, for a program, as well as treatment effects. And a key differentiator from other platforms is both that it focuses on research results, not, say, geopolitical outcomes, but also that it's really getting magnitudes and not just, will it replicate or not, for example. We have got over 75,000 human forecasts made and almost 500 active forecasters on these 147 research studies. We've also put out a working paper based off of the first 100 studies that were posted on the platform. So how do people do at forecasting? Well, here you can see a distribution of forecasted treatment effects. So this is all in terms of standard deviations. You can see there's a large mass at zero, people predicting no impact, but also a very long tail, sort of binned up at that high end. And how does this compare to the actual realized treatment effects? Well, turns out the humans are over-optimistic. Your forecasted treatment effects had a mean of about 0.18, median of about 0.1. The realized treatment effects, they're considerably lower. The mean is around 0.1. The median is around 0.04 standard deviations, okay? Okay, humans are over-optimistic, fine, but there's still some signal in their forecasts. If you plot their forecasts against the actual treatment effects, you can see, there is some signal there that you can then use for things like power calculations, experimental design. So what you can also do is you can improve on those forecasts. So I won't focus too much on this slide. You can read more details in the paper because I'm going to try to focus more on LLMs. But you can, for example, shrink the forecasts. And you can also put different weights on the forecasters who you might think of as somewhat like super forecasters, let's say. Those who are performing very well, you can put more weight on them, and you can downweight those who are doing very poorly. Although there's still some kind of wisdom of crowds effect. You maybe don't want to completely discard even the ones at the bottom of the distribution. Still put some weight on them, just a very small amount. Okay, great. And I was referencing how it can improve experimental design. Well, here is some example of that through thinking about power calculations. So if you look across, say, down that first column, you have got the typical treatment effect of around 0.1. Well, people are actually forecasting, seemingly, from how they're designing their studies, forecasting something larger of around 0.12 for themselves, and getting their own sample size of around 2,000 some on average observations. That leads them to, when you look at how their study actually, resolved, and I know you're not supposed to do sort of power calculations after the fact, but if you are looking at that, you get, the actual power would have been actually pretty low, very underpowered, which, leads to all these concerns we have got about the literature. But if you were to use sort of some optimal forecasts, remember I was saying you can shrink the forecast down, you can place more weight on the super forecasters and whatnot, you get a forecasted effect that's much smaller, much closer to the actual treatment effect. It will inform you that you need to power up your study a lot more. You need to have many more people in your sample. But then you will end up with a better power in the end. And if that sample size is too much for you, fine. You can have some decision rule that says, for example, if a forecasted effect is under 0.05 standard deviations, you're probably going to have a real hard time finding a real effect at that point. There's some treatment effects also that are so small you really don't care about them. So suppose we take, hypothetically, for sake of argument here, 0.05, and we say if it's above that, we'll run it, and if not, we won't run that arm, or we won't collect that outcome. We just think it's not going to be powered. So if you were to do that, you would be able to get a lower sample size, but still maintain those benefits of the increased power. Okay, so this is just like a toy example here, but based off of some real data of how that might improve things on the power side. But what is everybody interested in here is how the LLMs are doing. Okay, so let's look at that. So the top part of this is the humans, and the bottom part here is the LLMs. And I already sort of showed you some of the human results where you've got, you go from your individual forecast to your wisdom of crowds effect is really huge. You can shrink it down, you can weight it, but if you look at the LLMs, their average forecast is already better than the shrunken human forecast and very close to this optimally weighted human forecast. And the shrunken LLM forecast outperforms that. This is off of all of the data for which we can do this. And not only that, but they also seem to have more signal to them. Now, it's interesting, actually, that the LLMs themselves still were a little bit over-optimistic, but there's still some signal. So you can get even better power calculations out of that. You can see that the N that you need increases, but also the forecasted power is also correspondingly higher. Previously, you were getting improvements to 0.6 power. Now you can get to 0.7. Obviously, we kind of want 0.8 as a norm, but it's still doing a lot better than the 0.4 that you might have started with. Okay? So, great. We have some improvements from that. Now, the natural next question is, yes, but do the humans still add some value? You could imagine putting some weight on the human forecasts, some weight on the LLM forecasts. And the immediate answer is it looks a little bit disheartening in the sense that, okay, so we start with, you have your shrunk average forecast and for the humans and for the LLMs separately, those first two rows I've already shown you. And now we go to weighting them both. So you can see sort of here the coefficient on the human forecasts, the LLM forecasts, the optimal human forecasts, and the LLM forecasts. And what if you want to put a certain amount of weight on the humans and then 1 minus that on the LLMs? If you were to do that, you get that bottom row there. And these are all out-of-sample tests, so there's going to be some natural variability and noise here. Basically, it kind of all looks the same, like after the LLMs, that you're not actually getting much additionality from putting any weight, really, on the human forecasts. But there's potentially some saving graces. That was using all the results. And you might think, well, there are some surveys where you have got, for example, so taking a step back, on the social science prediction platform, we have this nice panel that ensures that projects that post there get at least 40 responses. However, sometimes people want to do additional randomizations within their survey. They maybe want to ask more questions than they really have time for. So the individual authors can choose to sort of make their forecasting survey in such a way that they actually get relatively few responses to any one given question. And so if you have really few responses, you're not going to get much of a wisdom of crowds effect from the humans. So if we sort of look at that subset of studies where we have at least 20 forecasts, then you can see here, okay, that shrunk optimally weighted one is still technically a little bit better than our shrunk LLM forecasts, okay? But I'm not going to want to really hang my hat on that, right? I do think that the LLM models are improving all the time, and so, will this persist is a bit of an open question. But given all that, you might naturally wonder, okay, where do we go from here? And you can just sort of speculate about alternative approaches of doing sort of LLM-only forecasts, which are very quick and easy to do, or more ensemble approaches. There's actually is a thing for LLM-only forecasts already out there. I put this together in February, where you can get feedback at an early stage of your project design, which I'm also flagging because Devin had mentioned about the importance of doing things early in the process to correct things. When you've got your pre-analysis plan or registered report or other document, you can sort of get some initial feedback early on about whether you've included all the things you might want to include in there. Currently, the way it has been set up is, so this is from a frequent co-author, you can get a little summary of your plan, you get some strengths, you get a little badge if you clear all the fields, you have all the fields listed there. There's many more fields that are extracted, including all your primary outcomes. The way I had been thinking of this is it could also serve as an input to later downstream tools, like some people in the audience might be familiar with like RegCheck and other things like that, which check whether you did the thing in your pre-analysis plan. But clearly, if your pre-analysis plan is vague or inconsistent, you're not going to be able to use those tools as well. So it can directly feed into some of that. But I'll just jump to a different thing here, and this is from a different project. Which somebody had reached out and invited me to, where it was a conjoint experiment. There's actually a power assessment section of this, which will also sort of evaluate your power and give you some feedback just based off of the LLMs. So obviously, there are issues with LLMs. They can be inaccurate. They can be biased. But they do give feedback very, very quickly and easily and make substantive suggestions about things you can do differently. The alternative approach that you could imagine is something that's more of a human and LLM hybrid. And just like how if you look across multiple LLMs, you can have a wisdom of crowds LLM, actually. Well, humans might still add some value to that, too. So this slide is taken from some analysis that Mantic did. They were looking at predictions on Metaculus. And you can see here the optimal ensemble way up in that sort of top left area, different individual models, their sort of fine-tuned approach. But to my knowledge, it's, so first of all, there still aren't these sort of human and LLM hybrid things for research results out there, which is where the social science prediction platform can fit in. Yeah, so just to sum up some things in this area. So there is some signal, both in human forecasts and in AI forecasts. They do overlap substantially, though, and I think it's clear that right now the LLMs are beating the humans sort of head-to-head. That's not to say that it's impossible for there to be additionality for humans, potentially on certain types of questions or in certain areas where they can really benefit from that wisdom of crowds. But I do think, over time, we should expect to see fewer and fewer of those areas. But that's great, because then, if we can sort of get quick, easy LLM forecasts to more people, that can inform the study design more. I think a lot of people are still a little bit reluctant to post a forecasting survey if it'll take time to get human forecasts, if it's an effortful kind of process. Just to flag a couple of other things in this space. So there is seemingly going to be this big forecasting tournament, externally sort of sponsored, where basically what we're doing is extracting all of the publicly available pre-analysis plans on the AA-RCT registry, as well as trying to get some other ones as well, and extracting the forecasting questions from those using LLMs in a similar kind of approach as I showed earlier. Then actually there's going to, hopefully, if all goes well, be a very big prize attached to that to try to encourage forecasts from anybody, including maybe even frontier labs, to compete. So I do think there's potentially a lot going on still in the future in this space. I'm also working with Jason Abeluk and Ray Gao on sort of automated forecasts based off of quantitative analyses. Basically, you can let the LLMs loose over observational data, and they figure out their approach to analyze the observational data, as well as do that kind of econometric analyses and develop forecasts from that work. And for that, we're looking at actually clinicaltrials.gov instead of the AA registry. So that's all to say there's a lot going on in forecasting. I think there's a lot still to learn. Hopefully, though, it will improve the studies ultimately that are done if we can set up the experimental designs better in the first place based on them. Thank you.
Probably have time for one or two questions.
I'm hoping my ignorance of statistics and of LLMs cancel each other out. For this, but the LLMs are not trained on human forecasts?
They're not in what I showed you today. We did try to train them and then look out of sample. The reason I wasn't showing those results today is they're very prone to cheating. Cheating. So, so for example, I tried to do the Karpathy auto research approach, if you're familiar with it, where you let it sort of recursively self-improve itself. I set that running, and then by round 9, it was already saying the answer to this is, in its own documents, if you looked inside of, what it was doing. So this was actually completely unprompted. Just, tell me what the answer to this thing is. And the results were not already part of this, at least as far as we can tell. Now, could it go out there and search online and maybe find something? So we tried to look at that by seeing if there was anything that it predicted 100% correctly, if it had identified some outside source. We didn't see anything that was 100%, so hopefully not. But the other thing that we're hoping to do in the future is as more results become available, we can look at results past the cutoff training date of some of the earlier models. So right now, it's a little bit hard to do because the best models all came out around September 2025, and there are few results that have resolved after that point. But hopefully we can soon start to include some of those sort of things as well. Does that answer your question?
Oh,
I see. So Yeah, so like I say, we haven't trained them on the humans for this, but you do see, actually, it's interesting that they do have some of the same human biases of like over-optimism. Like they're also reading the biased literature. Yeah.
But one thing is I bet they have been trained on studies. Just we don't know it, right? I mean, we don't have access to what data they were trained on. So, one question I had was, is there any chance that is similar to what you were asking in a way, that if you limit yourself to studies that had surprising results, that humans might do better at that, forecasting those, than LLMs, which are much more interpolating machines, kind of?
Yeah, that's a good idea. We can look at that. We haven't looked at that yet, so I don't have an answer, but it's a good thought.
Hi, Mario Manichkin from Stanford University. We've seen with the agentic AI that you can now have survey respondents being generated of a representative population of the United States, or someone to give you sort of responses. So what are you expecting here? When you're saying prediction, you want the correct answer rather than the LLMs actually imitating what the predictors would do. So ideal LLM in this case would give you the same biased result as the predictors rather than giving you the correct result if you're asking it to be representative of the predictor population. And so there are strains in survey research where are trying to do this is you can have LLM correctly answer a question, be it a mathematical problem or whatever it is, or you can have it responded in the way that an average population would respond it or an average researcher. And I think those are two different questions of what are we aiming it to do.
Yeah, so we're not actually asking it to forecast what the humans would forecast, but we are asking it to forecast what the results of the study are, and you might think the results of the study themselves are maybe still biased. So you could also think one step further is, forecast not just this study, but what would a replication of this study find? Or many replications. You had a question. I don't want to leave you waiting, if there's time.
Yeah, I was just wondering if you had an idea about what the accurate predictors were basing that on, if you were able to get to the underlying structure of what made an accurate prediction, whether it was human or LLM.
Yeah, that's a good question. So we haven't had much in the way of why questions, but we do know attributes of forecasters that a little bit indirectly maybe tell you a little bit about this. It doesn't seem to be very much in the way of like domain knowledge, actually. It could be that we don't have specific enough domain knowledge to matter, but we asked for things like, are you a development economist, a behavioral economist, and so forth, and those kinds of fields don't seem to matter for your forecasting skills. We also see that people who are systematically very confident about their forecasts are actually wrong, which you might think goes against some past literature which suggests that people who are more confident, there's actually some signal there that they actually do know something. But I think the difference here is that because we have a panel, it's still true that with individual fixed effects, holding to fix the type of person you are and how confident you are in general. If you're more confident, maybe there's still a signal there. But then there are just some overconfident types who, if you're confident about everything, then you're wrong.
But what part of the experiments are they basing?
Yeah, I mean, we don't know, I don't think. I mean, like, we haven't done... some teams, there are some why, like sometimes you have like an empty field at the end for like, why did you do this, but not sort of systematically. We do ask people for their own expertise though about, have you done a study in this location before? Have you done, so we do know a little bit about people's expertise.